Hi, CP Algebra 1. This is the review for the Unit 4 test. Notice I have a couple of equations up at top. This is slope-intercept, and this one is point-slope. Point-slope, so we'll just call PS for point-slope. Notice how the B value is 0, comma B, and the slope is attached to the X. And then slope is attached to the parentheses, and then you pull a point out. When you pull a point out, this is opposite, this is the same. All right, so we'll use that going through each problem. So this first one's in slope-intercept form. So we have a point at 0, comma 2, which is right there. And I have a slope of negative 3/4. So from the point I just made, I'm going to go down 3, right 4. And connect the dots. Make yourself a straight line, arrow on both sides. This one is in point slope. So the point is going to be the opposite what's inside the parentheses and the same what's outside. And then we're going to have a slope of 2 because that's out front. So plot the point -5, -3 first, which is down here. Then I'm going to go up 2, right 1. And that's how you work that problem. The next problem is in point slope form. So our point is going to be opposite inside the parentheses, same outside. Our slope is going to be 3. So I'm going to have 4, comma 1. Our slope is going to go up 3, right 1 from that point. Connect the dots, put an arrow on both sides of your line. Next one is in slope-intercept form. So my point is going to be 0, -4, and my slope will be 3, or 3/1. So plot 0, -4 first. From that point, you're going to go up 3, 1, 2, 3, right 1. Connect the dots to each other. Put an arrow on both sides of your line. Problem number 5 is in slope-intercept form. So our point is going to be 0, comma 5. Our slope is going to be, there's no number there, so it's got to be -1. So -1/1. So 0, comma 5 is up here. And then I'm going to go down 1, right 1. Connect the dots to each other. That's what it looks like. All right, this one's in point slope form because the reason I know it's in parentheses. So I have a point of -3, 6. So -3, 6 is like here. Out front, I basically have a 1 out front. So I have a slope of 1/1. So I'm going to go up 1, right 1. Connect the dots to each other. There we go. Number 7. This is in point slope form. So my point's going to be -1, -7. So -1, -7 is down here. And my slope is going to be 4/3. So from that dot, I'm going to go up 4, right 3. And then they want to know, is this an increasing or decreasing? Well, as I go to the right, is the graph going up? The answer is yes, so that means it's increasing. If I went to the right and it was going down, it would be decreasing. So let's take a look at this next one. This is in slope-intercept form, so I get 0, comma 2, which is here. So I'm going to go down 3, right 10. That's way over there. So again, that's my slope is -3/10. As I go to the right, is the graph going down? Yes, it is. So it's decreasing. Number 9, this is in slope-intercept form. So I have a point at 0, -4. 0, -4 is down here. Slope is -6/5. So from here, I'm going to go down 6, right 5. Connect the dots to each other, put an arrow. As I go to the right, is it going down or is it going up? It's going down, so it's decreasing. Problem number 10, this is in point slope. I have -2, but I don't have anything out there, so nothing out there is 0. So -2, 0. It's right here. And my slope is 4/1. So from this point, I'm going to go up 4, right 1. Connect the dots. As I go right, is my graph going up or down? It's going up, so it's increasing. Okay, go to the next page. We want to solve each problem, so I'm going to try and show all steps. So I'm going to add 7 to both sides here. First, cancel out using a calculator. Go -16 plus 7. -16 plus 7 is -9. Divide both sides by 3. X is equal to -3. Now realize it's an equal sign, so we're not worrying about any inequalities. Problem 12, I'm going to add 1 to both sides. Those cancel out, so I get negative 7x is equal to 35. Divide both sides by negative 7. Those cancel. 35 divided by negative 7 on a calculator is going to give you an answer of negative 5. And again, these are not inequalities. We're just solving them. There's an equal sign. Problem 13, I would distribute over the parentheses first. So negative 5 times x is negative 5x. Negative 5 times negative 1 is positive 5. That's equal to 30. Start solving it now. Subtract 5 from both sides. Those cancel. And then divide by negative 5. So x equals 25 divided by negative 5 on a calculator is negative 5. Problem 14, I have a denominator. So I'm going to multiply both sides by this denominator. What that does is it cancels the denominator out, leaves me 2x plus 7 on the left side. 3 times 3 is 9. Start solving it. Subtract 7 from both sides. Those cancel. So I get 2x is equal to 2. Divide both sides by 2. Those cancel. 2 over 2 is the same thing as 1. Problem number 15. Now we have x on both sides. So we just have to start someplace. I'm going to subtract 3x from both sides first. Those cancel. So 11x minus 3x is 8x plus 7. Subtract 7 from both sides. So that's negative 16. Negative 9 minus 7 on a calculator is negative 16 equals 8x. Divide each side by 8. Reduce. Negative 16 over 8 is negative 2. You could use a calculator on that. Number 16, I'm going to subtract 7x from both sides. Those cancel, so that's 3x plus 4. It's equal to negative 14. Subtract 4 from both sides. Those cancel. 3x is equal to negative 18. Divide each side by 3. If you go negative 18 divided by 3 on a calculator, you get negative 6. Number 17, I'm going to combine these like terms first. So negative x plus 5x, that's negative 1x plus 5x is 4x plus 7. And then I'm going to distribute over the parentheses. So I get 4x minus 8. Now let's start doing it. I'm going to subtract 4x from both sides. Uh-oh, we just found that 7 equals negative 8. Is 7 equal to negative 8? No, it isn't. That's false. So that means we have no solution. That's your answer, is no solution. Number 18, we're going to combine these like terms first. So 2x minus 5x is negative 3x. Minus 8 equals 7. Let's add 8 to both sides. Those cancel, so I get negative 3x equals 15. Divide each side by negative 3. Those cancel. X is equal to negative 5. 15 divided by negative 3 on a calculator is negative 5. Number 19, let's not be afraid of the fractions. I have a 2 on the bottom. I have a 5 on the bottom. 2 times 5 is 10. I'm going to multiply everything in the problem by 10. And when I do that, 2 goes into 10 5 times. 5 times 1x is 5x. 10 times 6 is 60. 5 goes into 10 twice. 2 times 3x is 6x. And 10 times 5 is 50. All right, now we can start moving things back and forth. I'm going to subtract 5x from both sides. Those cancel, so 60 equals x plus 50. Subtract 50 from both sides. 60 subtract 50 is 10. So 10 equals x, or x equals 10. Again, we have a denominator of 3. We have a denominator of 2. 3 times 2 is 6. I'm going to multiply everything by 6. So what's going to happen here is 3 goes into 6 twice. 2 times 7x is 14x. Minus 6 times 3 is 18. 2 goes into 6 3 times. 3 times 1x is 3x. And 6 times 8 is 48. Let's go ahead and subtract 3x from both sides. Those cancel, so I get 9x minus 18 equals 48. Add 18 to both sides. Those cancel, so 9x, put an x in there. That's an x in there. Equals, if you add those together, that's 16, that's 60. Did I do that right? 8 plus 8 is 16, carry the 1, 66. So 9 divided by each side. So 66 over 9 would reduce to 33. Let's see, 3 goes in the top, so that's 22. 22 on top over 3. You can leave it as 22 over 3. If you made it a decimal, that's okay. If you want 66 divided by 9 or 22 divided by 3, you get the same decimal, so you could do that for an answer. Okay, problem number 21. We want to solve for x. G and x are being multiplied together, so I'm going to divide both sides by g first. They cancel, so x equals h over g. 22, we want to solve for x, so x and y are being held together by addition, so I use subtraction to undo it. So z minus y. So x equals z minus y. For problem 23, oops, let's get rid of that. Uh-oh, all kinds of fun stuff's taking place. All right. L and W are being held together by multiplication, so I'm going to divide both sides by L and W being multiplied together, so I'm going to divide both sides by L, so those cancel out. W equals A divided by L, or A over L. For number 24, LWH are being held together by multiplication. You want to get W by itself, so I'm going to divide both sides by LH. So the L cancels, the H cancels. So W equals V over LH. There's your answer. Problem number 25. I want to solve for x. So we're going to add 3 to both sides. Those cancel, so 2x equals 14. Divide each side by 2. 14 divided by 2 on a calculator is 7. Number 26, we want to solve for x. So I'm going to add 3y to both sides. Those cancel, so 2x equals 3y plus 11. Divide both sides by 2. Those cancel, so x equals 3y plus 11 all over 2. For problem number 27, we want to solve for y. I'm going to add 5x to both sides. Those cancel, so y equals 5x plus 7. It's positive 7 in the original problem, so put a plus sign. Problem 28, we want to solve for y. So I'm going to subtract 4x from both sides. Those cancel, so 2y equals z minus 4x. Divide both sides by 2. Those cancel, so y equals z minus 4x over 2. Notice the fraction is the whole thing. For problem 29, we want to solve for c. So what I'm going to do is I'm going to multiply both sides by 5 first. So I get 5f equals 9c plus 32. Then I'm going to distribute 9 over the parentheses. So I get 5f equals 9c plus 9 times 32. That's 18, 27, 288. Then I'm going to subtract 288. Is that right? 9 times 2 is 18. Yep, it is. I subtract 288 from both sides because I'm getting c by itself. Those cancel, so I'm going to get 5f minus 288 equals 9c. Divide each side by 9. So those cancel out, so that's what c is equal to right there. Problem number 30, we want to solve for x. So first thing, I'm going to subtract b from both sides. Those cancel out, so I get y minus b equals mx. mx are being held together by multiplication, so go ahead and divide each side by m. m's cancel, so x equals y minus b divided by m. All right, so we want to write as an inequality, make the interval, and draw the graph. So we'll make the inequality, draw the graph, and then we'll do the interval. So I'm going to subtract 5 from both sides. So x is greater than or equal to -8. On a number line, I have 0 here, I have -8 down here. This is going to be a solid dot at -8 because I have the equal sign, and I want values greater. Remember, if you have your x value on the left, when you solve it, that arrow points the direction you go. My interval notation is going to be a square bracket from -8 going to infinity because that's pointing to infinity. Problem 32, I'm going to multiply both sides by 6 to get rid of that fraction. X is less than or equal to 18. Let's draw the graph first. So I get 0 here, I get 18 down here. Solid dot on 18. And remember, if the x is first, or letters first, you shade the direction that it points. So this is pointing to negative infinity. Redo the interval notation, reading it from left to right. So it goes to negative infinity to 18. And it's going to be a hard or a square bracket because I had the equal sign. Number 33, I'm going to add 4 to both sides first. Those cancel, so I get 3x is less than 12. Divide each side by 3. Those cancel. X is less than 4. So let's put it on a number line. If I have 0 here, I have 4 here. It's an open dot, and it's going left. Because my letter is first, the arrow points the direction we're going to go. This is pointing to negative infinity. Interval notation, read left to right. Negative infinity to 4. And this is going to be a parenthesis because I don't have the equal sign. Number 34, I'm going to subtract 5 from both sides first. Those cancel, so negative 2x is less than 12. Divide each side by negative 2. When I divide by a negative, my inequality sign changes directions. 12 divided by negative 2 is negative 6. Let's make the number line first. I have negative 6 here. I have 0 here. It's an open dot at negative 6. Arrow points the direction we shade. That's pointing to infinity. So the interval notation is going to be around at negative 6 because I don't have a solid dot. I don't have an equal sign to infinity. Number 35, you could go, if you wanted to, you could distribute the 5 over the parentheses first. That's fine. So you get 5x minus 10. It's less than or equal to negative 40. Add 10 to both sides. So negative 40 plus 10 is going to give me negative 30. And then I'm going to divide each side by 5. Those cancel. So x is less than or equal to negative 6. So negative 30 divided by 5 is negative 6. Let's put that on a number line. I have 0 here. I have negative 6 here. So there's going to be a solid dot at negative 6, shading to the left because it points. That's pointing to negative infinity. Interval notation, take from your number line, left to right. Negative infinity to negative 6. Square bracket at the negative 6 because there's an equal sign, solid dot. Number 36, multiply both sides by 9 first. Those cancel. That's 18. Add 4 to both sides. Those cancel. X is greater than or equal to 22. So on a number line, you have 0 here. You have 22 on the right of it. It's a solid dot at 22. And it's going to shade forever to the right to infinity. Use your interval notation as a square bracket, 22 to infinity. That's Mr. Meows. Okay, we're going to go minus 2x plus 6 is greater than 9. Subtract 6, subtract 6. Statistics, probability. 9 minus 6 is 3. Divide both sides by negative 2. Those cancel. Divided by negative, sign flips. So I get negative 3 over 2. So on a number line, you have 0 here. You have negative 3 over 2 here. This is going to be an open dot going left. That's pointing to negative infinity.
This is what we're doing today?
No, I'm recording.
Oh.
So you're on forever on my recording. Soft bracket or parenthesis at negative 3/2 because there's no equal sign. Number 38, I'm going to add 2x to both sides. Those cancel, so 10x plus 3 is greater than or equal to negative 17. I'm going to subtract 3 from both sides. Those cancel, so 10x is greater than or equal to negative 20. Oops, I forgot the x. X is right there. So divide by 10. X is greater than negative 2 or equal to negative 2. Put that on a number line. So you have negative 2 here. You have 0 here. Solid dot at negative 2. Shade it to the right. That's pointing to infinity. Your interval notation will be square bracket negative 2 because it's a solid dot. There's an equal sign to infinity. Infinities always have a parenthesis. Last two problems. Subtract x from both sides or 1x from both sides. Those cancel. So 12 minus x is 11x. Add 4 to both sides. Is greater than or equal to 7 plus 4 is 11. So I combine two steps there. Divide each side by 11. So x is greater than or equal to 1. So I have 0 here. I got 1 here. Solid dot at 1. And go to the right. That's pointing to infinity. So my interval notation is going to be a square bracket. Because it's a solid dot, there's an equal sign to infinity. Last problem. Subtract 2x from both sides. Those cancel. Negative 10 plus 2x is less than 6. Add 10 to both sides. Those cancel, so 2x is less than 16. Divide by 2. So x is less than 8. On a number line, I got 0 here, I got 8 here. Open dot at 8. Go to the left, that's pointing to negative infinity. Make your interval notation, negative infinity to 8, round parenthesis right there. This review should help you along with the test. There was an awful lot we did. Okay, we're spending 2 days going over this, so don't think you have to have it all done in one day. If you have extra questions about anything that's written on here, ask your teacher to verify why something is a certain way. Have a great day. Good luck on your test.